Hey guys, Colin here. Hope you're well. So today we're going to take a look at a Word doc file which was used to deliver the Trickbot info stealer recently. The particular Word doc we're going to take a look at, you can see here, has got quite considerable detection on VirusTotal. 34 out of 58 engines detect it as malicious. And I wanted to show you this particular sample because I found it really interesting, the way in which the bad guys have firstly obfuscated their VBA code in order to kind of evade human analysis, but also just some of the techniques that they've used as well in order to execute processes under the hood. I found pretty interesting. So I thought worthwhile sample just to kind of spend a little bit of time on, and you can see kind of my thought process behind how I analyze this kind of code from a code analysis point of view, as well as behavioral as well. So we'll dive right in. I'm just going to use my Windows 7 machine here, virtual machine, and just look in my settings. Out of interest, I've got the network adapter set to host only, just because I can't be bothered, if I'm honest, infecting my machine and rolling it back. I can just deal with the kind of network connection that I know this particular sample makes, and it's obviously not going to reach its destination. So I've got the copy of the document here on my desktop, and I guess from a behavioral monitoring point of view, or behavioral analysis point of view rather, we're just going to monitor the processes that are created and that get created and the processes that exit within Procmon, just so we can see the kind of flow for what happens. So let me just kind of move that screen over here. And then also you can see as well that I'm proxying my traffic through Burp Suite just to capture any network activity as well. So if I open the document, you'll be able to see that it encourages me to enable macros, and it says like loading content or whatever. So that's a joke. And if I click on enable macros and click OK, we should see it try to reach out to the internet, which the aim of which is obviously to download its additional payload, which in this particular example was Trickbot. So we can see here it makes a request, or it starts to at least, to onyxtools.com /public.png. So that's cool. And if we look in Procmon at what actually happened, let's have a look under the hood here, and I'll just stop the capturing just to kind of speed things up a little bit. We can see that WinWord spawned cmd.exe, and there's a command line there where it invoked bitsadmin, and so it kicked off this bitsadmin request, and you can see the various parameters which are passed to bitsadmin, and then the URL as well. So it uses this like live off the land binary, as they're known, which resides in system32, in order to pass it a URL in order to download and then subsequently execute. So pretty easy. Additionally, you can see as well that it was creating a scheduled task. So if you like, let's make this a bit bigger, and then copied all of this out into like a text editor, for example, you can see the full command. So it's like two commands in one. You've got the bitsadmin transfer, and then that gets written to the temp directory, and then you've got a scheduled task which gets created, and I think it's for like 10 minutes after you execute it. The scheduled task will then fire in 10 minutes time to execute that downloaded file that's now stored in your temp directory. So it doesn't run it straight away, it kind of sits there for 10 minutes, and it might be some kind of like sandbox evasion technique or whatever that it's using. So that's pretty interesting. So that's all it does effectively. So let me come out of here, and if we wanted to see like the actual macro code, let's go into Visual Basic and macros. We can see that the bad guys have password protected the VBA. And there's numerous ways that you can get around this. There's tools which you can use which will just strip all the VBA out for you and just kind of bypass it. You could open it in LibreOffice, for example, which will just kind of bypass that protection automatically. Or a method that I like to use is if you stick it in a hex editor, HXD, you can search for the string DPB, and here is like the hash of the password effectively, but you can invalidate it. Just change the DPB to like DPX or whatever, hit save, and that will like invalidate the actual authentication. So let's go back into developer, Visual Basic. We can see we get like an error because it says, right, it's got an invalid key now, and we get an unexpected error. So that's fine, no problem. That's what we kind of expect. But you can see we kind of get in now. But we just need to just take the protection off, put it back on again, maybe set a new password. I'm just going to write hello. And what I like to do is just kind of close it down and save it, and then reopen it again. And then hopefully what you'll see is when we go into the macros, type in hello, we now didn't get any errors this time, but we can access all of the VBA. And you can see this is so noisy, it's unbelievable, and it's really difficult to read as well. So the bad guys have used like long and very similar variable names. There's an awful lot of comments in here which look like Latin, so that's just to kind of like really confuse. And there's just thousands of lines here, which is just crazy of all code. And we really our task is to work out like what's in this code that we might be missing from our behavioral analysis, or does what we saw in that behavioral analysis completely corroborate what's in this code. So I'm interested to know like how it created the network connection. I also want to see as well from an my point of view if there's any additional indicators we can get from it, but also just work out like how it created the process of cmd.exe. One of the first things I would do actually is look for the word shell. It says it's like search text not found. So that's interesting. So it's not like executing a shell. Or I'd look for the string run, and you can see here that it's like in the comments or in like some rather random variable names, but it's not actually it's not using a run command. Sometimes they use exec, and the search text is not found again. So I'm curious at this stage as to how it's actually how it's actually happening. For ease of demo, what I've done is I've just copied out all of that Visual Basic, the VBA code, into Sublime, just because I find it easier to read and navigate around, if I'm honest with you. So I'm not actually going to execute any code here because this is on my host machine, but I'm just going to kind of start sifting my way through the code so you can get an idea of how I kind of clean this up and the mentality I have when I'm analyzing this kind of stuff. So this is the original. I'm going to work on a copy just out of interest's sake. But you can see the first thing that actually the bad guys have done here is they've defined a few things up at the top of the code. So before, in the kind of namespace here, they defined a couple of function aliases. And like anything with like kernel 32 in it would just like raise alarm bells. So you can see straight away that they've created this alias for create process A. Which is obviously a bona fide API call from kernel 32, and then the same as well for get startup info. So those two super interesting to me. So if you wanted, you could just control and find them, and you can actually see that on line 506 here, this is where the create process string is being, or the create process API call is being used. And the second, if you looked it up on an MSDN, the second parameter to create process A is the command line, and there's various flags here as well. That get passed in, and we'll talk about them in just a second. But the first one is the command line, and you can see the command line is actually stored in userform1 textbox2.value. So that's weird, and you want to have a look maybe at userform1, see where else that's kind of mentioned in the code. We can see that it only exists in these two locations, so we can see that the value is set in this particular line here, 481, where there's obviously some strings being built up and passed into this particular parameter, this particular method of replace. We're not going to get into the weeds on that just yet. What I want to do, let's kind of take a top-down approach and have a look at the code. So we know that it's using create process A and get startup info, which is probably like fed into create process A. So let's have a look. When you open the document, you can see here we've got this document open routine, and we've got what looks like quite a lot of noise. So we've got these big strings which are being declared here, which just look really noisy. And there's no science to this. I'm just going to kind of presume at this stage that these are noise, and I want to look for like where's the first meaningful line of code here. And I can see here there's a call instruction. So there's a call to this particular function on line 25. So let me just double check, right? So this variable, control and F it, well, I only see it mentioned in 2 locations. So it's probably noise. The same for this one. It's only like mentioned here. It's not referenced anywhere else. So if it's not being used, I'm just going to kind of treat it as like as potentially unwanted, and it's just completely noisy. So actually what I'm going to do is I'm just going to delete all of this just to make it a little bit clearer. And we can see here that like you have like methods for tan, absolute, there's some like addition and subtraction routines, exponential. It's just so noisy. It's just like pointless code. So I'm just going to delete everything that's in between it. We can see there's another call to the same function. That's quite interesting, actually. And we can see there's more of the same. And I'm not verifying this at this moment in time. I'm just presuming this is all noisy. But you can see there's another call to another function, and then there's a load of noise. And then you can see that and maybe there's some other stuff as well that again just looks like noise. So let's have a look at first off this particular function that's called twice, because that's pretty interesting. I don't know why something would be called twice, but we can certainly investigate that. So the first function, let's just make a little bit of space here. Well, it returns a long, which is like a long integer, and we have the same kind of pattern. So there's like this big strings that are being declared or defined here, and we can see as well they're not used anywhere but for this particular location. When I'm debugging a function, I actually start from the back and work my way backwards through the code. So I start to see like what the function returns first, and then look to see how the return value is built up. But you can see here that the return value is just literally the integer 1. So it doesn't matter what actually goes on in between all of this stuff. It's just going to return the integer 1. So it's just a pointless function. It's probably there to throw you off your analysis. And to be honest with you, we can just get rid of it. So let's get rid of that and get rid of that. And what we're left with here is this particular function call. And so let's jump to this particular function and see what it's designed to do. So you can see as well, this one returns a long integer. And actually, again, if you can start to see the kind of pattern a little bit. So we've got some really big long strings being defined, and then some like what looks like noise in the same kind of pattern in between. But if you see here, one thing that sticks out is this split function. So there's like a parameter that's passed to split, which is the output of this particular it's this particular value or variable which is fed into this particular function twice, and then whatever the output of that is, it seems to be being split by a pipe symbol. So that's interesting. So let's have a look and see what's being passed to split. Well, you can see actually, if we control F it, it's this particular long string here. So this one is not actually noise. And if you scroll right to the end of it, you can see that actually there's an equal sign at the end of it. So that's a little bit, a bit of a giveaway of the potential encoding that's being used. So we'll treat that one as potentially we want to have a look at that. The other ones, we can see, there's some other usage maybe on that one. So we'll leave that in for now, and maybe some other usage on that one as well. So that's interesting. But let's, for now, because that's got an equals at the end of it, let me open Chrome here and let's go to CyberChef, which is my favorite tool of choice for kind of decoding and putting recipes together and stuff. Let's feed this string in. I think I had an equals sign at the end, though I copied the wrong one. So yeah, it's got an equals at the end, and we'll say from base64, and we can see here that like we get like another load of garbled kind of string together here. But if you remember, let's go back here. It was passed through to this particular function twice. So I'm going to make a guess right now that that's a base64 decoding routine, and it's probably double base64 encoded. So we'll test our theory, and we'll just say from base64 again, and actually what we get is some plain text. So that string there is that, and you can see it's easier to read here, isn't it? C program data malware byte, C program data Panda security trend micro, Alterogasti, no idea what that is, Kaspersky Lab, and Mentos Bells, again, no idea what that is. But you can see that's a string which is delimited by the pipe symbol as well. So that's really interesting. So I think what we've got, let's go back to our code here. Whoops, where's it gone? Let's go back to our code. This particular function then is a base64 decoding routine. Let's just go and find that here in our code. We can see that the function resides on line 14, and it looks quite noisy, but I've no need to debug it because I know the output is going to be base64 decoded. So that's great. I can just kind of like put some comments around that and say, right, base64 decoding routine. Awesome. Okay, let's go back to our code of interest, wherever it's gone. Scroll down here somewhere, isn't it? Let me search for the split. I'll get back to where we were. Okay, cool. So this stuff here, I'm going to presume is noise, but we said that like these strings might be in use. And then again, we see some like square, int, whatever. It just looks noisy, so I'm just going to remove it for now. And you can see that actually here, there's a for loop, which is going from 0 to 5 in steps of 1, and something is happening in the for loop. Well, there's a little bit of noise. I'm going to get rid of that. And we can see here there's an if condition, an if block being defined. So that looks noisy, but we got a value which being set to 102. I'm going to leave that for now in case that's relevant. And these look a little bit noisy as well. So let me just get rid of these here. And there's an else clause as well. So let's just kind of tidy up the syntax a little bit so we can read it a little better. So let's have a look at this for loop. So for 0 to 5, what's going to happen is it's going to check to see if a directory exists or not. So basically, if a directory does not exist, so it's blank, so if directory, and it's going to pass in each value in the array that we've just split. So if we go back to CyberChef, it's going to pass in C program data malware bytes, and it's going to say, is that a directory? Or if it's not, rather, then it's going to set this particular value to 102. And then it's also going to set this particular variable at the end here to 102 as well. So that's, again, a little bit noisy, but basically we're going to come away with either a variable having the value 102 if the directory does not exist, or 349 if the directory does exist. So that's interesting, and we don't know where that's going to be used just yet. And actually, here's the end of the if statement here as well. So it's probably like that. And end if like that. Let me just get it right. End if. That's probably your syntax right there. Okay, cool. And then there's like an if block. Let's get rid of this noise in the middle. So if the value that's returned from that directory check, you can see here, is less than 250, for example, so it's going to be like 102, then do something, and then so it's going to set a variable here. So let's just clean up this noise, get rid of that. That looks noisy, get rid of that. And also that looks a bit noisy, and so get rid of this out of the else clause. And I could be deleting code which is really important. I don't know yet, if I'm honest with you. This is just kind of guesswork as you kind of go through it, but we shall soon see whether or not anything is relevant. Again, that looks a little bit noisy because it doesn't really do anything. So let's just tidy up the indentations a little bit. So if it's like less than 250, so the directory does not exist, then we're just going to set this other variable to 137. If the directory does exist, I'm going to set the variable to 331. And you can see here that that variable, 137 or 331, is just passed in as a parameter to this function just down here. And so actually, that looks like noise, so we can get rid of it. Okay, that's cool. And then so the first parameter is going to be like the output of, what are we talking about here? So weird how they kind of mess it all up, right? So we get the value of 102 here stored in this particular variable. And that's passed to this variable, which again is passed. Oh, I see. So 102 is always passed as the first parameter to this function, and then the second argument is either 137 or 331, which indicates whether or not the directory exists. So a little bit bizarre, but we'll go with it. So we'll say 102 equals param1, and param2 equals like whether directory exists. So that's interesting. There's obviously some reasons why, like they're gonna, and this looks all noise down here as well. So there's obviously a reason why they want to check to see whether those directories exist, and so we can actually look for that in our behavioral analysis to see whether or not anything changes later. So let's jump to this particular function. So yet more noise to have a look at, and we can see here that we've got a similar kind of pattern being formed. So we've got this strings being defined, but let's see if we can kind of make it a little bit more meaningful and see if we can work out what's going on here. So it looks like, let's just double check that this particular variable is not being used anywhere, and it doesn't look like it is. So I'm going to skip all of that, but it looks like the pattern repeats here. So we've got this variable, and we can see it's being referenced in a few places. And then you can see, let me just get rid of this line, this line, these few here. And you can see that like there's a variable name, and then they've just like thought, stick an underscore 2 on the end of it. So we've got this string which is being built up. So this line, and this line. So 1, 8, 4, 5, and 6 get concatenated together. And then 1, 8, 7, 8, and 9 get concatenated together as well to form two different variables. So that's interesting. So these that's one variable and that's another variable, and then you can see here that we have let's see what's going on next. So we have a variable which being passed as a string, passed into the string function. So the first parameter is being converted to a string. Okay, that's perfect. Okay, let's go back actually, because I'm not convinced. Let me just double check the parameter here. So this parameter equals, oh, I see. I missed a step. I beg your pardon. I thought it was weird. So this the first parameter of this particular function is actually whatever this equates to, and I didn't check whatever this equates to, right? So apologies, and I'll just go back on myself a little bit. So I guess it's like part and parcel of doing some live malware analysis. So let's just copy and paste this and see what this variable is. Actually, what we find that variable to be is a function. So it's the output of whatever this function is. And again, this function is like super noisy. And to reverse engineer this function, I'm going to look like at the return value of the function and see where the return value is built. So you can see here the return value is like itself plus a variable minus a variable, but we're in a for loop. And so we can see here, let's just get rid of these because these look noisy to me. We can see there's 1 plus 3 and there's 4 plus 5. So simple maths, obviously. And let's just get rid of these here because, again, I reckon these are noisy. So let's just clean this up a little bit. And this all looks like noise apart from the return value here at the bottom. And so we've got a for loop which goes from 0 to like whatever that is, 238 million and something. But bear in mind it goes from 0 to 238,740,913. So that's 238,740,914 times. And what happens is we take our variable and add to it 4 plus 5, which is obviously 9, and minus 3 plus 1, which is obviously 4. So we're just adding 5 each time. So what that says to me is we've got 5 times 238,740,914 times, because it starts at 0, which is this crazy number. So the return value is this. So that is actually what's being passed into this function. And that is going to be the first, oh, I see. So that's the first parameter as well. So let me go back to my calculator here. Copy this crazy value. So, okay, cool. So let's have a look at this function again where we started. So I beg your pardon. So the first parameter is that big value here from my calculator, whatever that means. And then the second parameter is like whether or not the directory exists or not. Okay, so we'll come to that in a second. And we worked out that there's a couple of variables that are being built up here. And then so the first thing that happens below that declaration is our big long number here gets converted to a string. So let me get rid of these because these look a little bit noisy. And then we can see as well what happens to the output of that string. Well, we can see here it's used. Let's just get rid of everything in between. We'll presume that everything in between is not necessary. So what happens in between is so it gets converted to a string, and then that string we extract a substring of that string. So we start at position 3 and then get the next 2 values from it, and then we turn that into a value, back into a value. Now this threw me off a little bit, if I'm honest with you, when I first looked at this, and I've only looked at this I think twice now. But what I'm just going to do, I'll come back to what my thought process is in just a second. But let me just kind of clear up the rest of this code here, because I think we can pretty much work out what this is doing in just a few clicks here. So I think this is all noisy. And like I said, this is not scientific, but hopefully I can see that same routine being used again. This is the base 64 decoding routine, if you remember from earlier. So let's just get rid of all this stuff. That looks all noisy as well. So it's a simple if else. Okay, let me just take a step back then. So our big long number that gets passed as a parameter gets converted to a string. Then we take a substring starting at position 3 and taking the next two characters. So if you did that, your sense would say position 1, 2, 3. I would start at 1, so I'd start up at the 9, so position 3, and get the next two characters, which would be like 3 and 7. But actually what happens is, bizarrely, if you convert an integer to a string, I don't know why, and I might be wrong, but I think like a trailing or a leading whitespace character is inserted for some reason. I'm not quite sure why. And so actually the number that we end up with here is 19, and I'll demonstrate that to you in just a second. So we get the number 19, and then what happens is we take another substring. So this line here, where we see mid, we're just taking a substring of a string. So this is the string we're going to take a substring from. And so this is this big long string that's declared up here. It's going to start at whatever this value is here. And that start at value we just worked out, and I'll show you, is 19. So it's going to start at 19, and it's going to get the next value, which is just another one position along. So let's just have a look at what the value would be. So you can see I've selected 18 characters. So it's going to start at 19 and just take the next one character. So that is that character, f, lowercase f. So that's all that is returning. So that's lowercase f. And then so there's some other stuff that goes on here, which we'll just have a look at in just a second. But if you don't, it's weird, right? That like starting position. But let me just kind of prove that a little bit, because I, in anticipation, created a document with some macros to show you what I mean. And I don't know whether it's just me, but so here's, I've kind of replicated the code. So here's the big long number, and here's the string that we're interested in. So I convert the number to a string, and I take a substring from it, and I'll just debug.print it. Then I'll take the substring of the big long string that should produce the letter f, and then just produce the ASCII value of it, and debug.print that as well. So let me F5 that. I need to enable macros. Sorry. Options, enable macros. That would help, right? So let's go back into that. Let me F5 it, and you can see that it takes the string 19, and then it converts it into 102, because 102 is the ASCII representation, or the decimal representation of the ASCII character f, lowercase f. But let's just say I don't convert it to a string, and I take the mid value, so the middle value of 119370540. I start at position 3 and take the next two characters, and then just debug print the value. You can see here there's 93, which is what like your intuition says it should be. So I don't know whether it's like a weird VBA thing that if you convert the number to a string, you get a different result, and whether that's because it has like a leading whitespace character. I'm not sure. Maybe someone can answer in the comments. But anyway, that's what's happening anyway. So we end up with the value of f, and if we go to ASCIItable.com, this is my favorite, lowercase f is the decimal value of 102, and this will become relevant in just a minute. So what actually happens is, we can see here that if this particular variable here, which is the second parameter that we passed in, which was determining whether or not the directory existed, so if it's less than all of these added together, which is 128 plus 56, 94 plus 22, I took a gamble and said that's 300 in my head when I did this, and allow me to just double check myself. Plus 22 is 300. So if it's less than 300, then basically we're going to base64 decode this value, which is this string that's concatenated together. And if it's not, if it's greater than 300, then we're going to base64 decode this particular string, which is the second variable here, which gets base64 decoded. So that's interesting. So we have, let's start to build a recipe in CyberChef. So let's just kind of exit it, get rid of all the stuff here. I've got a big string that's being concatenated with that, and it's being concatenated with that. So we'll just work from the first one. So we know it's being base64 decoded, and you can see here that we get a load of ints separated by @ symbols. That's a bit weird. So we can see, right, so after the if block, we can see there's a split method which takes in whichever one of those variables we're using and splits it based on the @ symbol. So let's presume all this is noise and get rid of it. And then here you can see that next to that split, we can see we enter a for loop. So again, let me just presume that this is noise, and we can see here, we'll come back to all of this stuff. This is really the kind of money shot, because we can see there's a for loop which iterates over the length of that string, or the length of the array, sorry, I beg your pardon, that's now split by the @ symbol. And we can see there's an XOR routine here. So let's split this, and we can do it in CyberChef. We'll change the delimiter ourselves, and we'll join it with a space. So we're going to split it, and then we've got this for loop which iterates the array, and then what happens is each entry in the array gets XORed with this particular variable, and that variable is what we defined up here as the letter F. And so what we need to do, we can build, so actually what we need to do is treat this as a char code, and so it's in base 10, be sure to change that, and then we're going to XOR each of those character code values with the letter F. Now you can type, if you want to, you can type in UTF-8 here and just put the letter F, and actually what we get in, or if you wanted to, F in base 64, sorry, beg your pardon, F in hex is 66. So whichever your preference is, XOR to the same value, obviously. And we can see here that what we get is what looks like a base 64 encoded string. So what happens is, after that for loop, we can see here there's another call for that, for whatever the output is, for to be, sorry, I beg your pardon. So the output is stored in a variable which is reused. The name of the variable is reused, and what's being passed here into this base 64 decoding routine again is the output of the XOR. Okay, so that's obviously super interesting. So let's base 64 decode it again. So base 64 decode from base 64, and actually, oh, I didn't copy it over. So there. So that's the output. So that's the encoded command, which has now been decoded by our CyberChef recipe. So we can see that's exactly what we saw in our behavioral analysis. So what you'll notice though, there were two strings, and whether or not that directory existed, so whether those like program data, Kaspersky Labs, whatever those directories were, if they existed or not, was dependent on whether we'd use this particular variable. So let's get rid of this, and we'll start to build up this one and add in all of these. And you can see here that the command changes. So weirdly, if any of those like antivirus kind of folders are present, we'd invoke PowerShell instead. So rather than being CMD, you would see that bit transfer would be actually executed via PowerShell, and the same C2 as well. So that's just the behavioral nuance, and I'm not exactly sure why the bad guys have done that, if I'm honest with you. And again, maybe one that you can help me answer. And then you can see the rest of the code. I'll kind of spare you, if I'm honest, the debugging of this. But all the rest of this stuff, and all that looks really noisy. But you can see here, there's some like, this is where we got to earlier when we first started looking at the code. User form 1 textbox2.value, and that's going to be fed. If we have a look, the value of that command, that decoded command, is now going to be fed into userform1.textValue. And then there's some other stuff here which is probably not relevant. But then here we can see the call, if I just control and F it, is the call to create process A. And that's where userform1 textbox2.value, which is the decoded command that we've just decoded, that's where that gets fed to create process. And then one thing to note as well, and I had to go to a mentor of mine, Cyber Kramer, who should definitely tweet more and definitely do some more blogs and stuff because it's about time. But I wanted to know what the process creation flag of 32 was in decimal, which in hexadecimal is 20. And he kindly helped me understand that it's probably a normal priority class, which basically means that this thing is going to just often run and execute. So we're not going to like invoke this process or create this process in a suspended state or anything. It's just going to be treated as a normal process. And then some other stuff which is fed in here, which are like pointers to the startup and things like that. So you should definitely look up on MSDN the create process A kind of function itself, and you know, all of the parameters that it requires. But essentially, that's they've gone with kind of default parameters to get this this process off and firing. And then the rest of the code is essentially that's it. This all actually looks like noise. And so effectively, that's all this code is doing. We can see this is all the stuff that we've looked at previously as well. And so we can see that during our behavioral analysis, we saw those strings for the antivirus vendors, and so that's, you know, something that you can test for in your environment to see, you know, what difference it would make, and maybe during your analysis going forward, you'd benefit from making sure you reverse engineer all of the code to pull out any of those kind of nuances as well. So hopefully that's of use, and you understand the kind of mindset and the thought process I go through in the analysis techniques that are used to look at malicious macros. And just because they're really scary in how they're written and obfuscated doesn't mean to say that you can't actually pull out some key indicators from them. So enjoy anyway. Thanks, guys. I appreciate all of your comments, and obviously, if you like the video, then please subscribe to the channel, and also you can follow me on Twitter as well at CyberCDH, and I look forward to hearing from you. Thanks, guys.